Hello everyone, I am Kate Smith, the Editor-in-Chief of All About Circuits. Welcome to this webinar presented by Vishay. Today you'll hear about Vishay's latest microBUCK family of synchronous buck regulators, including how they're addressing power-hungry data center industrial computer applications. It's going to be a really interesting session, so thank you so much for joining us today. Your presenter today is Simon Foley, the Market Development Manager for Vishay's Power and Linear IC Division. And Simon's got over 20 years of experience in this space. So before we begin, I'm going to encourage everyone to draw your attention to the bottom of your screen. If you're joining live today, there's a Q&A widget at the bottom of your screen. So at any point in time during Simon's presentation, please put any questions you might have for Simon right there in that widget. And at the end of the session, my colleague Jason is going to host a live Q&A. So take advantage of that. Don't get to talk to people like Simon every day. So without further ado, thank you so much for joining us, Simon. Please take it away.
Thanks a lot, Kate. And hi, everybody. Thanks for joining. And thanks for the opportunity to present our new SIC 4.5 series, microBUCK DC to DC converter. I've got the pleasure of spending the next hour with you. I'll probably present for the next 35-40 minutes. And then I'll try and answer as many questions as I possibly can, and then I'll get back to you with answers on any questions that we don't answer later on. I hope it's informative, I hope it excites you, and that you consider us for designing. So let's kick it off. So today's presentation, as Kate said, was on the SIC 4.5 series, 4.50, 4.51, 4.53 microBUCK DC to DC converter. So let's kick it off with keep it a bit of interest in what are they? So what are these converters? So they're the family of highly efficient, non-isolated DC to DC buck regulators. And you can see on the box on the right-hand side, inside the red box, you've got the MOSFET, the high side, the low side, the gate drivers, and the PWM controller, constant on-time controller. And it's part of a synchronous buck solution, which you can see the outside inductor, the cap, and the load. It also has the PMBus interface, and I'll go into a little bit more detail later on. It's our first series with PMBus interface, and it's part of the new portion for digital topology that we're working with. The 4.5 series is a range of products from 15 amp to 40 amp with a 1% accuracy over the temperature range. But at 25 degrees, at 3.3 and 1 volt, it's got 0.5% accuracy. So it's a very accurate, very efficient solution from 15 to 40 amps. Okay, next question. Who are they for? They're for everyone. They're everyone, really. They're everyone who wants to, every engineer that wants to design a single phase point of load converter, who wants to reduce size, reduce conversion losses, heat and thermal management costs, and who wants the live performance monitoring and failure analysis that you get with the PMBus interface. Let's look at the trends and challenges in power delivery. And I think you're probably aware of this anyway, the way that the market's going. So for ICT, what we expect is for the power consumption to be tripled in the next decade. And you can see that from the graph on the top right. Now, ICT, which is consumer device products, data centers, mobile devices, Wi-Fi, everything that we use these days. So the power consumption is going to triple. And so I'll go through the market trends and also the power challenges. So the consumption is going to increase. So the power challenges there are increased efficiency. We need to offer a more efficient solution. The next is cooling. Cooling costs rocketing in data centers. I think for that, as you're probably aware, the more power you dissipate, the more power that's needed, the more power that's dissipated, and the more expensive it is to dissipate that heat and cool the device. So the power challenges there are to improve the thermal management. And that's something we're working on, and we cover that later on in the next few slides. Again, with the trend, CPUs and SoCs are becoming more power hungry. And again, the power challenge there is to increase the load transients, to give it very, very quick transients. And we do that with our constant on-time topology. Again, we'll cover that later on. High portability and less space in electronic devices. Really, what the challenge there is to increase the power density. And then more stringent and tougher application environments. Ambient temperatures are going up, which again relates to thermal dissipation. And then we need to offer a more reliable solution with higher temperatures to dissipate the heat, more efficient. So all these things come together And there's one word we need for this, and it's integration. So this is what we're looking at with integrated solution within our device. Okay, with integration, it's great. You can say we integrate. It's not just integration. There's a number of factors that go along with integration. You need, I've picked 5 key factors on this one. We need the leading edge MOSFET technology, trench FET technology, our state-of-the-art trench FET technology, which is integrated into the device. And again, I'll show you a picture of exactly what it looks like inside. This is the package you see in the middle. So leading edge MOSFET technology, innovative control IC design. We design our own controllers and we match them with the MOSFETs, and we design the MOSFETs to match with the controller. So everything's packaged together and designed accordingly. Advanced multi-chip packaging. It's great to say, I mean, what by that I mean it's great to have the best MOSFETs, the most efficient MOSFETs, the most efficient and the best transient controller, but we need the package to go along with it, low parasitic inductances, thermal management. So this comes hand in hand. And the highest quality and service standards. Again, we need, as Vishay, we are a leading manufacturer of electronic components. So we've got the highest quality and service standards, but that's already there. But it's one of the key 5 factors we need to be successful. And the last one is custom products tailored to custom needs. We look at the market, we look at the trends, and we design accordingly to see where the trends are going. Okay, let's look at the advantages. And on that, I like this specifically because there's a picture of the internal characteristics of the internal device. So the key advantages, let's start on the top left with the controller, COT controller, constant on-time controller, a wide range operating range, 4.5 to 20 volts input, with the PMBus 1.3 interface for telemetry. And again, at the end, we will go through more about the PMBus interface later on. On the top right, we've got the high side MOSFET. Again, we design the MOSFETs accordingly, state-of-the-art technology, and it's with Q-switch, QGD, low QGD, low Q-switch specification, and then that reduces the switching losses at higher switching frequency. And underneath the clip here, I'll come back to the clip later on, the low side MOSFET. Now the low side MOSFET, again, is important. We need low RDS on. It has an embedded Schottky, a SkyFET, which is the Schottky is embedded within the MOSFET itself. It's not parallel, it's embedded. So that reduces the QRR. And also we offer low QGD to QGS ratio for DVDT immunity to stop any voltage spikes going back onto the gate to have false turn on. And then all this is great, but what we need again with the controller, the high side, the low side, is the package. We need clip technology. It's a QFN package and it's clip technology. Now what that means is that there's a clip over the low side MOSFET and covering the high side MOSFET, and that connects to the switch node. What that does, by having clip, it reduces the parasitic inductances that you find in bond wires. It reduces the current capability and improves the thermal spec as well. So as much detail goes into the package as it does with the controller and the MOSFETs. Okay, where is the SIC45 microBUCK used? And it's a question I get a lot, you know, where can it be used? Well, it can be used in any application that uses a digital controller, an FPGA, an ASIC, system on chip, core power supply. Anything that you need to power with point of load from an input rail from 4.5 to 20. And that could be any application. And probably every application will need a point of load somewhere if it's got electronic devices. And I've got here the focus market applications: telecom, data centers, industrial, embedded PC, industrial automation, and consumer. But it's pretty much everywhere that needs point of load for a digital controller. Okay, moving on then to how does an SIC45 series microBUCK help solve design goals? Well, what we offer is higher efficiency. Again, going back to the challenges I showed earlier: small solution size, high power density, ultra-fast transient response because of the constant on-time topology. Scalability provides cost-performance optimization. Now, I love this. Scalability provides cost-performance optimization. So what do I mean by that? What I mean is it's scalable. You can design for specific current output for specific load. And then if you want to change that because something changes, the load changes or the application changes, you don't have to redesign the board. you can use lower currents and higher currents that have the same footprint and the same pinout. So you don't have to redesign. It's flexibility and a scalable solution. Again, I'll show that in the next couple of slides. Also, the PMBus interface. Now, the PMBus interface is new to us. Before we didn't have it. Now we have it in the 4.5 series. But what does it do? It really offers the designer greater flexibility to finalize and optimize his or her design. It provides live performance monitoring and failure analysis. So it's really, you're sitting there as from your microprocessor, you're sitting there looking at exactly what's happening from the converter, whereas you didn't have that in just a pure analog solution before. This is what I mean about scalability. So on the top right, you see the graph, and you'll see a 450, which is 40 amps, 451, and a 453. So 40 amps to 15 amps. And scalability means that it's the same package for all three devices, the same pinout, and you can design for one, and then you can replicate into multiple point of loads through the board. So you can design once and then replicate. It's a great way for flexibility. It saves time for the engineer, and time again is money. And it's flexible because you can pop a 25 amp solution up to 451 and replace it with a 450 without changing the design, just because the load has changed. It's in a 5x7 package QFN. And if I can just elaborate on that as well, the scalability is higher than competition as well. So the scalability is better than we see anywhere else. So again, more flexibility from us with a PMBus. Looking at the highlights, it's versatile, and it's versatile. What that means is the operating voltage is from 4.5 to 20, so you can handle 5-volt rails, 12-volt rails up to 20. Adjustable output voltage from 0.3 to 12 volts, and the resolution is pretty tight as well. It's a 1 millivolt resolution from the output voltage. And then moving on to the high efficiency. So we say high efficiency, 97.5%. Now that's peak efficiency. Here we use the 40 amp device, and you can see it peaks here at 97.5, and then it's 95% at full load from 12 volts to 5 volts at 600 kilohertz switching. So for just stopping and thinking about what it does at the moment, it offers a very efficient solution in a very small package, and also combined then with the high configurability, the PMBus 1.2 compliant. It offers you the flexibility with the PMBus, the digital interface as well. It's got an internal non-volatile memory, and also it supports if in multi-phase, so if it's in phase or out of phase. So if one can be the master, one can be the slave, or they can be 180 degrees out of phase, synchronized, or they can be in phase. It's flexible, it's configurable, it's efficient, it's small, it's versatile. Okay, there's more details, and the more details online with the data sheet, and there's questions at the end, we can go into it as well. But I want to come into now the design tools, because it's great having the microBUCK solutions, but we can't just give you the product. You can't just get the product and design it yourself. You know, we offer the design tools that help you as much as possible to design in the product. So there's 3 categories here. There's the Powercut, online Powercut tool, which is a free simulation tool, which is online, and I'll go through that in the next few slides. We have evaluation boards and dongles available, so you can set up, and that interfaces with the Vishay GUI, the POL GUI software, and again, coming onto that later on. So there's 3 categories to help you design. The first one is the Powercut tool. Now, it's a free online simulation tool, online on the Vishay website. You'll find it through microBUCK or microBrick on the Vishay website, or by just typing in Vishay Powercut, will take you to that link. And on it, you can use it to design before the evaluation board, just to check the performance, check the efficiency, the load and line regulations, to see if it's right for your application. So on it, you've got online schematics. We'll give you online schematics. It will there's a calculator in it as well, so it will calculate for the schematics the right peripheral component values for your application. You could as well, if you've got a lot of time on your hands, you can go into the data sheet, use the formula in the data sheet and do it, but this will actually calculate it for you. It makes the designer's job a lot easier than just looking at the data sheet and calculating. It will give you functional analysis tools as well based on Simplest. It's like Spice, and it will give you line, load, regulation. So you can really look at line load, inputs, outputs, as you would if you were working in the lab. It will give you the waveforms as you would with a digital scope. So you can set up the waveforms or the scope as you want it. You can zoom in. And I'll show you that in the next couple of slides too. It'll give you the efficiency, the power loss, and the thermal analysis. You won't see this anywhere, the thermal analysis. This is a bonus compared to anyone else who's got a similar Powercut online from competition. So efficiency, power loss, and thermal analysis. And again, I'll take you through a slide just to show you a teaser of what is available. And then it will give you a bill of materials. It'll give you a bill of material from your conversion spec so that you don't have to choose the components. They're already there. You can print it out and use those parts as well. And what this will do, we use as many Vishay components as possible on the build as you would expect, because we're part of the Vishay group. And then you can save and download or print a full design report as well at the end of it. It's a pretty impressive free tool, a simulation tool online. Okay, let's get into that in a bit more detail. So you get to it through the Vishay website. This is the first page you get to. You get the part selector, and it goes left to right. So part selector, configuration, analysis, bill of materials, and report. You have to register, so you have to register as a guest, but if you want the most out of it, you have to register your email, location, for example, or your country, and then password, and then you can go back into it at any time. So you can save it, go back into it, rather than starting again. So on the top left, you've got the widget, and you can put your V in, V out, and I out that you need for your application. On this one, because it's the 4.5 series with the PMBus, you can check the PMBus telemetry as the red box is there. And if you check that, in the bottom left-hand box, you get 3 of the part numbers, which is in the series 450, 1, and 453. As I said, range from 40 amps to 25 amps. So this will give you that from the first page part selector. And then what you do is you can click whatever part you want, if it's 40, 25, or 15, and it takes you into the next stage of configuration. If you keep on going further, you get the efficiency and thermal analysis page. And I just wanted to show you this because I think you need good eyes to see it. But on the top graph on the top, you see the yellow line, which is the efficiency. The ones on the bottom are the power losses, so the low side, high side, inductor losses. So you can break it down. You can see the efficiency. On the top right, you see the losses broken down into core losses, high side, PCB losses, and it'll break it down into category to show you exactly where the losses are. On the bottom left is the configuration, so you can see the 12-volt input, 25 degrees C, 600 kilohertz switching, for example, and an output of 25 amps. And you can set that as well. So you can set that and you can run it again without going back to the previous page. Then you get the performance on the right-hand side of that, where you can see the efficiency. You can see the performance as you move the cursor back and forth. So as a cursor, the red cursor, I can't do it on this obviously, but you can see the cursor on the top graph, and if you move that back and forth, it will change all the parameters. So on the boxes in the middle where you see the circles, the discs, as you move the cursor left to right or right to left, you will see the temperature change on the inductor, high side, low side, and the IC. And it will give you there the power losses at each point of the cursor as you move the cursor, and also the temperature. So this is pretty unique to ours, and you can see whether you're overstepping the mark from a temperature point of view, where you need to force air or you need to improve the thermal characteristics of your design. And then on the bottom right, you see the operating profile of the efficiency, the switching frequency, etc. Switching frequency is great because there's 2 modes. There's FCM mode, which is forced conduction, continuous mode, or there's power save mode. And if you're in power save mode, you will see the frequency reduce as the load reduces. And in FCM mode, forced continuous mode, you will see a pretty stable switching frequency as you set at the start of your design. Okay, onto this page. Now, I wanted to show this because this is a nice way to look at the device. You're almost in the lab. You're in the lab here with the online simulator as you would be with a digital scope. And what I've done is I've set this to just look at the output. I've looked at the output, I've run the simulator, and I've run it from 0.1 amp up to 25 amps. And on the left-hand side, you can see in the blue, you see the inductor current. The ripple you see in orange, and the blue line, which is pretty difficult to see out there, the square wave here, is the load. So the load goes from 0.1 amp up to 25 amps. On the left, then you see the inductor current, and this is in power save mode. So you as expected, the blue trace here will show a reduced switching frequency, and as the load increases to 25, you'll see the switching frequency increase. And this is where what you get with constant on-time topology, pseudo switch frequency. This in power save mode, it would increase the switching frequency at full load. And when you come back down to 0 or 0.1 in this case, you will reduce the switching frequency into diode emulation mode. That does two things. It gives you instantaneous power far quicker than it would without constant on time, but it also gives you the efficiency at light loads and maximum switching and maximum efficiency at full load as well. And from this, you can select on the top right, you can click and you can hide different things. If you don't want to see the inductor current, you can hide it or remove it. And it's pretty difficult to see, but you see vertical markers and horizontal markers. So you can set that up to actually measure the droop in V out as you increase the load, looking at load regulation. And you can also do the same for line regulation if you wanted to do that as well. On the bottom left, you see all the values from as you see, and you can, there's a nice cheat box there. So you can click the arrow and you can show me the delta between V1, V2 and H1, H2. So it actually, without measuring, if you want a pretty lazy day, it will give you the result of time or voltage as you would expect from a digital scope as well. It's a pretty impressive tool. Okay, so that was the simulator, online simulator, the Powercut. Now we move on to the GUI software. Now the GUI software is needed. I mean, it's preferred because you're developing and you're designing the DC to DC converter with a PMBus interface. So really, you want to know what it's doing. You want to make use of the PMBus interface, and for that, you need to download a GUI software onto your notepad, laptop, or desktop. So what that does, it allows the user to program the SIC45, optimize the design, and monitor the key performance. So you can set the parameters, and then you can sit back and monitor as you use the evaluation board, and you can monitor as if it's sitting inside the IC itself, and see if is it performing the way it wants to perform in the application. Are you happy with it? I think it's a great software, great tool, and a great product. The software itself, it's a simple process. It's not difficult. It's a single installer file. It's available for Windows, Linux, and Mac operating systems, and it's a standalone software. You don't need any drivers to go with it or pre-installed anything else. It's all there from that one download onto your desktop or notepad. Okay, again, you've got the GUI, you've got the product, but you need the evaluation board and you need the interface dongle that interfaces to the GUI, and we provide this as well. So the GUI software will be available online, probably by the end of July, I would have thought. The product is available now, and also the dongle and the eval boards will be available by the end of July as well. So we'll have the product, we'll have the evaluation board, we'll have the GUI and the dongle, everything you need for your lab to design and check the product to see if it's suitable for your application. More about the GUI itself. Now, this is the overall picture here, and what you can do with this, once it's downloaded onto your system, you get it onto your screen, and you can configure this. There's the configuration menu in the middle, and you can move these around depending on how you want to see it, how you want it to look. It's not just fixed. And on the left-hand side, so the configuration is in the middle, and this allows you to configure. So you want to, with the GUI, you want to configure it. You want to look at your thresholds for warning. You want the switching frequency to be set. You want the output voltage to be set. You want alarms to be set. You can configure it as you want, as you would expect with a PMBus interface. I mean, that's the purpose of it. And on the bottom right, you've got the telemetry, so you can actually see live performance. what's happening to V out, V in, etc. In the middle and the bottom, you've got the PMBus log, and that will show you an updated log as it's communicating between the GUI, the dongle, and the device itself, the microBUCK itself. And then on bottom left, you've got the application log, which is probably more applicable, showing you what's happening. If you set something, if you change something, you'll be able to see it on the bottom left. And then the most important thing after that then is to monitor it. And I'll go into the next screen, which will show exactly how you monitor it. But the top left is the monitoring. So you've set, you've configured, you're looking at things, and then you want to run it and you want to see how it's performing. So a little bit more about the configuration. This is into more detail. You can set the switching frequency, for example, the PMBus interface. There's a lot more you can go into as well, but that would take us probably a couple of hours to go through. And then also for the configuration side of it, through the GUI, you can set your output fault thresholds. So when you do get a fault, you can set that level and a warning. So you can set a warning before it gets to. It's really configurable for the user to set it up as he or she wants. And then the most important thing, once you've set your performance settings, then you want to sit back and watch it. You want live performance monitoring as it's converting away. So it's converted in an efficient way, and then you can look at V in, V out, current in, current out, the temperature, and the power out. And because of the thresholds you set earlier, everything's running fine here because it's all in green. So everything's running as you'd expect. You can set orange, which is your warning thresholds, and then if it goes to red, if you've got a fault and something goes past your fault thresholds. But you can set all these yourself. And that is it. That's my overview of microBUCK. There's a lot more to discuss, and we can go into more detail. If you want more information, you can download the website, the datasheet, and you can contact us through icmarketing@vishay.com. So I think it's good to, if we look at the questions. Max, yeah, what do you think?
Hey, Simon, this is Jason Montgomery here. Can you hear me okay?
Hi, Jason. Hi. How you doing?
Hey, thank you so much for the presentation. I'm glad to hop on here and go through the Q&A here. To everyone that's in attendance, I'll just remind you, if you've got any questions, you can use that Q&A box. Your Q&A widget will give you the chance to submit some questions that Simon and I are going to go through right now. So let's see here. First question that I'm seeing is, does the SIC 45X, does the SIC 45X have a light load setting?
Yeah, great question. Thanks for that, Jason. It does. There's two modes of operation here. There's light load and there's FCM mode, force continuous mode. And the light load mode, settable by the PMBus interface, will fold back the frequency and it will keep it above 20 kilohertz, so outside the audio range. So if you want that, or if you want a more stable switching frequency, you can use FCM mode, and that will keep it to the switching frequency plus or minus 15%.
Perfect. Thank you very much. Next question is, can the series be synchronized?
Yeah, it's another good question. Yes, it can. This is the only series we have in our range because of the PMBus interface that can be synchronized. You can set one to master, one to slave, or if you just want to use one on its own without a slave, you can set that to master. But if you can synchronize from an external clock, if there's two in the application, you can configure it that they are in phase or 180 degrees out of phase. So the answer is yes, it can be either together or to an external outside clock.
Got it. Thank you very much. So let me pull up another question here. Where can I buy the evaluation board and dongle?
Okay, great question. It's available in July, probably the end of July, from your catalog distributor. I'll keep an eye out on the ones that you normally use, and they will be available there.
Got it. And what about downloading the GUI?
GUI, again, will be available July, probably end of July. It'll be available on our Vishay website. So it'll be a link in the documents for the 451, 450, 453, and in the documents you'll see a link to download the GUI. So yeah, from the Vishay website.
Perfect. And then I am seeing a question here, Simon. It looks like this might be a pretty specific kind of simulation tool question. I don't know if you can see that question. We might want to handle that offline, or I can read out the question if you want to go over it.
Let's go for it. Yeah, please, Jason.
Oh, cool. Okay, so the question that I'm seeing here is, when we use the Vishay simulation tool for either the 46 or 47 series simulation, changing L to the other, I think that's the microhenries, but the compensation resistance isn't changing. It's not any different. Do you have any clarification or thoughts about how that might be working?
Right. Okay. I didn't realize it wasn't working. It should work. It should change. So if you change the inductor value, it should change the compensation values as well for the external compensation. So it should. I will look into that. I'll make a point of it, and I'll make sure if there is a problem with it, we'll rectify it. But please, if you can for that, I'll probably get the email from this question, and I will respond directly to that person to make sure that we come back to you and we look into it. But it should change. It should change the compensation value, yes.
Okay, good. Good to know that that is something that should be working if everything's going as planned. So, and then for the person who submitted that question, they'll be able to reach out to you directly and walk you through anything else you might need there. So that's great support.
Definitely. I've spent months on the Powercut tool, so with the team we all have. So we're really interested to get it right for the user. It's important.
Fantastic. And that's what I love to see here, is kind of that direct engagement with these kinds of presentations, so people can actually get out there and get the stuff that they need. So thanks, Simon. Appreciate that. And we can give people a couple more minutes if there's any other questions that might be trickling in, everyone. If anything's come to mind, feel free to submit. And Simon, is there anything else on your mind that you want to touch on while we give people a second to submit questions here? Anything else that you want to reemphasize or anything like that?
Yes, I could as well. It's the news here. What we've seen a lot of engagement with customers that we've presented this to from our presentation through sales and applications. It's quite impressive. The feedback that people have had who have analyzed it, evaluated, are pretty impressed with it. We've got specific customers who have already evaluated and designed it in. Without the GUI, they've done it themselves. So we know from some focused customers we've worked on that it's pretty impressive. The efficiency is slightly better than competition. So we know it performs well. We've got a design in already. It's there. We're there to support. It's not just me and the team. There's a big team behind me in San Jose. There's applications. We've got sales. So any questions, contact us. We can answer anything. We've got an application team, so we can support you too. We're there to support you through the design, and this is part of us. And we're really excited to see where this goes and how successful we are in the next couple of years with this product range.
Great, thank you very much. Another question that we just had come in is, are there plans to do a high voltage automotive IC?
Oh, really good question. Yes, we do, and high voltage is all relative, I know, but we do have a 60 or 65 volt series coming out probably Q1 next year. It doesn't have a PMBus interface, and it will be, we start off by a 10 amp SiC Q481 and a 6 amp SiC Q482, and it'll be 4.5 to 60 volt recommended, absolute maximum 65 volts. Automotive qualified. We've made some changes to the 462 series to make it more efficient. Automotive qualified for telematics, for lighting. So that will be coming out Q1 next year.
Got it. Thank you very much. And well, Simon, it looks like we got through the bank of questions. We got through what was an outstanding presentation, I think. And I think we might be getting close to wrapping it up here. If there's anything else that you wanted to say.
From my side, thanks very much for attending. I know an hour can be long listening to a presentation. I hope it was informative. I hope it excited you enough to at least evaluate, at least get onto the Powercut tool and test it for yourself. The proof of the pudding's in the eating. Please consider us. ask us questions. We're here to support. But thanks for attending. Thanks for your. I think there's another question coming, Jason. Yeah.
Yeah, I think it's this one is when will we have automotive level DC-DC product? Is that
right, okay,
quarter
right.
next year? Same answer or?
Yeah. Automotive. We've got automotive product now, which is analog switch multiplexers released. We will have VR power samples available at the end of the year for ADAS applications for VR powered Dr. MOS up to 100 amps, which is the driver plus MOSFETs, where you need for multi-phase applications. And that is pretty impressive because it's more efficient than competition. It's pin for pin, slightly better. And that's exciting. That will be coming out, I think probably early next year release. So we've got VR power for multi-phase, and then we've got analog switch and multiplexers already released. That's the DGQ 405, 1, 2, and 3, and the DGQ 2599, I believe. 2588, 2599, and that's available now, fully released. And then the DC to DC converters, 6 amp and 10 amp, up to 60 volt, 65 volt maximum, come in early next year.
Got it. Thank you very much, Simon. Well, I'll start to wrap us up here, and if there's any more questions trickling in, we can get to those certainly. But Simon, thank you very much for joining us here today for an outstanding presentation and going through these questions. I know we had a good audience that was here and some really, obviously, a lot of interest around this. So thank you so much for your time and sharing your expertise with us.
No, you're welcome. Thanks, Jason. Thanks, everyone.
Yeah. So I'm Jason Montgomery with EE Tech and All About Circuits. You'll find plenty of other live webinars and on-demand webinars done by Vishay and plenty of other companies as well on allaboutcircuits.com. If you go to our industry webinar section, I know you'll find lots of resources from Vishay and the things that we've covered in the past with them. And I think this was certainly a good one. Let's see here. So I want to, again, thank Simon Foley and Vishay, and I'm Jason Montgomery, and we look forward to seeing you at another session sometime soon.